Hello everyone, welcome to Dakshana e-classroom program. So I hope everyone did their best in FST 23 paper. Let's talk about its solution for part physics. So starting with question number 1. A thin vertical tube of length L is inserted into mercury of depth L by 2. The top end is sealed and find the height h of the mercury column left in the tube after tube is pulled out of the mercury. Temperature is constant, atmospheric pressure is equal to that of the mercury column of height h. So here what it's saying, like let's say one container is having some mercury, and in this a tube is inserted and this is sealed. So the upper end is basically like I'm simply now, and some mercury is like it will be L by 2 because half of tube is immersed. Now in this situation here volume is equal to what? If I say let area of cross section of tube is A, then I can write it's this volume is can be written as A into L by 2. And let's say pressure in right now will be simply equal to P naught, atmospheric pressure. Now after this the tube is pulled out and this column, mercury column, will be like descending down and finally let's say it's staying only up to here. So this is H. Then this much is what? L minus H. So final volume, this is the like air has been from this length to this length, it has expanded, and it's mentioned in the problem that temperature is supposed to be kept constant. So temperature I will be taking simply T naught and T naught constant. So now in this situation volume final V final will be equal to A multiplied by L minus H. V initial already we have A into L by 2 and pressure initially is P naught. So now what will be the pressure in this situation? So if I take this is P, let's say P final, then I can write here P final plus rho G H is equal to P naught. And it is also mentioned that P naught is equal to rho G equal to the height H, capital H height of the mercury column. So that P naught can be written as this. Rho is the mercury of density, like density of mercury. Now I can write P1, V1 is equal to P2, V2, or P initial, V initial is equal to P final, V initial, V final. This implies P initial, it's P naught, or let me write it directly. So this is rho G H and V initial is A into L by 2. This is equal to P final. So P final will be equal to what? P final is equal to rho G H minus rho G small h. This can be written as rho G capital H minus small h multiplied by volume is A multiplied by L minus H. A gets cancelled, rho G also gets cancelled, and we are left with H L by 2, and this is H minus H into L minus H. This is the final expression. Now we can simplify here for small h, and solving finally we are getting like HL by 2. This is also HL minus plus H square minus LH minus HH, and that's all. So rearranging it, H square minus L plus H multiplied by small h, and this is plus HL by 2 equal to 0. And H is equal to L plus H plus minus under root L plus H whole square minus 4HL by 2 divided by 2, and this we are getting H is equal to L plus H plus minus, or I can write by 2, and this will be like all cancel out L square plus capital H square. This will be capital H. This we are getting now here. See L plus H and plus this will be like even higher, so that because it's already, this is also definitely greater than L by 2, and if I'm taking it plus, then this is also greater than L by 2. So the plus cannot be, because this H cannot be more than like L by 2, so that's why it will be only minus sign. So small h is coming out to be L plus this is also capital H, this is capital H, capital H by 2 minus under root L square plus capital H square whole divided by 2, and we can check the option which matches with the A. So this is question number 1. Next question number 2. A charged particle mass 1 kg, charge 1 coulomb, and is projected from 0, 10 with the velocity v. Uniform electric field exists in this region. Gravity also acting on the void. So now it's like simple question actually here. So this is the reason, and here 0, 10 particle is projected with 10 meter per second I direction speed, and see the force acting on the particle will be like 1 mg and another is q into E. E is mentioned as minus 10 I cap plus 5 j cap. This is a Newton Coulomb. This is the electric field. So now I can write net force F net is equal to QE plus mg, and this is equal to QE if I am substituting minus 10 I cap plus 5 j cap minus 10 j cap, and that comes out to be minus 10 I cap minus 5 j cap. So effectively, like initially particle is projected this way, the particle will have acceleration in this direction and in this direction. Because mass of the particle is 1, so I can write AX is equal to minus 10 meter per second square, and AY is also equal to minus 5 meter per second square. So because of that, sort of the motion will be something like this. It will be like this acceleration and this acceleration, net acceleration will be in this direction. Let me erase this part. Now solving for this, so its particle passes through origin at some time, so we can check whether it's like x coordinate is becoming 0 at some time or not. If there exists some time, we can say like means x and y coordinates should be becoming 0 simultaneously, then only we can say it will be passing through origin. So here let me first check when the x coordinate is becoming 0, and I will check that exactly at same time whether y coordinate is also becoming 0. So here like I can write ux is equal to plus 10 meter per second. I can write x is equal to 10 t minus half into acceleration is 10 into t square, and this is equal to 0, and this implies 10 t, this is 1 minus t by 2 equal to 0, and this implies t equal to 0 and t is equal to 2 seconds. So yes, x is equal to 0. I'm like x is 0 at 0 and 2 seconds. Let me check where y is becoming 0. So y I can write simply this is initial velocity 0, and this is minus 5 into t square, at square, this is equal to minus 10 finally, because from here to there final position will be 0 in y. So solving it, we are getting exactly t is coming out to be 2 seconds. So you can check at exactly this time y is also becoming 0 and x is also becoming 0. So yes, I can say the particle will be passing through origin. So A option, that's correct. Time spent by the charged particle in quadrant 1 is 2 seconds. That is also true, because by the 2 seconds the particle is passing through here actually, through origin. So it will be out of quadrant 1 by 2 seconds. Next, while crossing the origin trajectory make equal angle with both negative x and negative y direction. That we can check by checking Vx. Vx is equal to, this is 10t minus 5 v is equal to u minus at. So 10 minus a, 10 into t, and t is equal to 2 seconds, that's coming out to be minus 10 meter per second, and vy at the time of crossing will be equal to 0 minus 5 into 2, that is also minus 10 meter per second square per second. That means yes, it will be crossing exactly at 45-degree angle, so it will be making equal angle with negative x and negative y direction. Kinetic energy of particle at 0, 10 will be half of the kinetic energy at origin. So we can write kinetic energy K at 0, 10, this is equal to half m into v square, 10 square, that is 50. And kinetic energy at 0, 0, so net speed is coming out with this, that is half mass is 1 into its 10 root 2 whole square. So this is coming out to be 100. So yes, kinetic energy at this point is half of the kinetic energy at origin. So here A, B, C, D, all four options are correct for question number 2. So A, B, C and D all are correct. Let me first erase the board. Okay, next question number 3. And hollow spherical conducting cell of radius A has thin long wire connected to the top of the R is equal to A, comma, theta is equal to 0 and bottom this, and current I flow through the wire down the spherical. Out of the lower wire, the sphere is centered at the origin and the wire. So now it's asking, so the condition given in the problem, this is a sphere and wire is connected in this manner. So current is passing here, flowing in the surface of the sphere and finally coming out. It's like this. This is y and this is x-axis and its center is at origin 0, 0. So now the current will be passing in this through the surface of the sphere and finally moving left. This is at r is equal to a and this is 0 angle. Here you can take r is equal to a and pi angle. At the center of the sphere, magnetic field is 0. So you can definitely write due to this part of the wire and this part of the wire, B at 0, 0 will be 0. And what about this? So here I can take ampere loop, then we can write integral B dot dl. So I enclosed in that is also 0. This implies B is equal to 0. So that's right. Actually at center B will be 0. Next point, at point 0.5, 0.8 r magnetic field is, so let me just, it's 0.5 r and 0.8 r. So let's see first what is the distance, whether it's lying inside this sphere or it's lying outside. So I can write let's say r prime is equal to under root, this is r square by 4 plus this is 4, 16 r square by 5 means 25, or let me simply, so it will be 0.25 r square plus 0.64 r square, and this is coming out to be 0.89 r square. So definitely r prime is less than r. That means this point is also lying somewhere inside, and for that I can write again by Ampere's law, B dot dl is equal to mu naught into I enclosed will be 0, so B will be 0. So means it's saying at point 0.5 r, 0.8 r, 0, magnetic field is mu naught I by 1.6 pi r. That's not right. And exactly in same manner, next at point 0.3 r, 0.4 r, that will be also inside. So B is not right. C will be also not right, exactly in same manner. And at point 0.5 r and 0.8 r, we already checked it's lying actually inside. So definitely here B is coming out to be 0. So D is correct option. So A and D is correct for question number 3. Next question number 4. Two plain air capacitor with the same plate area are charged to same charge. The distance between the plate of the first capacitor is half of the second. Okay, now the first capacitor is inserted between the, so here situation is given to you. This is a capacitor 1 where charge is plus minus, this is QQ, and plates A, B, capacitance C1. Another system is this. So here also charge plus Q, minus Q, and this is plate D, C, and the capacitance is C2. So right now initially this is the situation, we know the charge on each of these plates. After this capacitor is inserted between the plates of capacitor C2, then the situation will become like this, and this is A, B, and this is yours. So now in this situation here, like it's minus Q and it's plus Q. This is the initial distribution of charge. Now if I let's just go with the distribution of the charge, then finally I will have, this is the situation of charge distribution between on each plate. So this is D, A, B, and C. On this plate it will be 0, and here it will be like plus Q charge, here it will be minus Q, and here it will be 2Q, it's minus 2Q, and it's plus Q, and here it's minus Q and 0. That will be the charge distribution finally after settling down everything. Now based on it I can answer the questions. So the potential difference between the plates of the first capacitor will increase after insertion. So potential difference, some E multiplied by D was V1, I can write E multiplied by D. In this situation, this is the plates of capacitor 1. Finally, the charge on this like 2q 2q, so definitely the electric field in this region must be higher, and E multiplied by D, so potential will definitely increase. So that first option is correct. A, it's right. B, potential difference between the plates of the second capacitor will increase after insert. Okay, so now see it. Right now, before this was inserted here, some, let's say I will say E1 is the field, and that will be like Q by A epsilon naught. Now in this situation, in this region and in this region, I can say the field is same, so the potential due to this contribution will be same, but this region also comes in between the plates of the second capacitor, and in this region you can see the electric field has increased, so definitely the potential due to that was like earlier contribution coming out of this region, now it has increased, so definitely the total potential difference between the plates of second capacitor must be increasing. So B option is also right. Potential difference between the plates of the second capacitor will increase after the insertion, that is also correct. If you want, we can even calculate the value also, that's not a big problem here. The magnitude of charge on one of the facing surface of plates of first capacitor will increase after the insertion, so that you must be already seeing, it's plus Q, and here it's also plus Q, so that's not right, it has not actually increased. The magnitude of charge on one of the facing surface of plate of the second capacitor will increase. I did mistake. First capacitor is this, and this is the second capacitor. So it's saying the magnitude of charge on one of the facing surface of the plate of first capacitor will increase after insertion. So yes, it has increased. It was earlier facing surface Q charge, and now it has become 2Q. So C is also correct option. B is right, C is also right, and D, it's talking about magnitude of charge on the facing surface of plates of second capacitor will increase after insertion. So on the plates of second capacitor, this is the plate of second capacitor, this is the facing surface, and this is the charge, and you can see the charge earlier and now it's same, so it has not actually increased, means D is not right option. So for question number 4 we will have A, B, C is the correct option. Let's see next question number 5. Okay, next question number 5. Assemble circuit shown in figure. EMF of battery E1 is 1.5 and EMF battery E2 is variable. Both batteries are ideal initially. E2 is such that current through it is 0. So here current through it I is equal to 0. Current here I can get simply let's say I1 will be equal to 1.5 divided by total resistance, that is 7.5. that comes out to be basically 1 by 5, it's 0.2 ampere. So the potential difference across this we can write V equal to E2 is equal to 4.5 multiplied by 0.2, that is 0.9 volt. So initially the E2 battery must have potential of 0.9, that means it's like B2 is correct. If E2 is if E2 is 2 volt, if E2 is 2 volt, in that situation what will happen actually? If E2 is, if I am making this is 2 volt, then what will happen actually here? Let me just ground this potential, here it's 0, so here potential will be 2 volt, and in this situation it's like 2 volt, and here it will be like 0.5, so some current will be flowing in this direction. So keeping same polarity, it is getting charged. No, in this situation the battery E2 is not getting charged, it's basically supplying charge. So A is not correct actually, it is not getting charged. Yes, even will be getting charged in this situation. So if E2 is equal to 0.5, keeping same polarity, it is getting charged. That we can see, right? See, if this is 0.5 volt, is it? In that situation, what will happen actually here? So this is 0, then 0. This is also 0.5. So what will happen actually? The potential difference across this will be 0.5. We can get the current here through this. Current through this will be like 0.5 divided by 4.5, it's 1 by 9 ampere, and current coming from here, we can get current from here. So this is like 0.5, then here it will be like 1 volt, is it? 1 volt, so we can get the current through this is 1 by 3 minus this current rest current will be passing through here. So yes, in this situation, if E2 is 0.5, it is getting charged. That's correct. D option. If E2 is increased keeping the same polarity, even may be charged, that we can write. So if let's suppose E2 is increased such that in that situation here the potential is E2 and here the potential is E2 minus 1.5 volt. So now see, what is the meaning of like even may be charged if E2 is increased? Even may be charged means whenever like current is entering into this polarity, this positive polarity of this battery, then I can say even will be charging. So that means some current must be flowing in this direction. So that means current must be there across this. So I can write the potential here must be higher or greater than 0. So that implies E2 minus 1.5 volt must be greater than 0. This implies E2 must be greater than 1.5. So in this situation, yes, there is possibility of even battery to be getting charged. So D is also correct option. Maybe, because it's saying maybe charged, that's correct actually. Is it? So if E2 is increased keeping the same polarity, even may be charged, that's correct. So that is question number 5. B, A is not right, C and D. Question number 6. Find the force in the hinged rod BC, AC and so on. Like, so a diagram is given to you. This and this. And it's, let's say, M. So mg is acting and this length A, B, C, and everything is mentioned. AB is equal to 0.6 meter, AC is 1.2 meter, BC is 1.6 meter. So if I take this angle is let's say A, this angle is B, this angle is C, then I can write is it? We have this relation that 1.6 divided by this length, 1.6 divided by this angle sine of A equal to 1.2 divided by sine of B equal to 0.6 divided by sine of C. Let's say it's X. Then I have the value of sine A, sine B, sine C, everything. So now we need actually like this tension is pulling, so it will be like getting compressed. So in this, and here it will be in tension. So let's say tension here it's T1 and in this it's T2. So now it's asking AC is in tension with force, AC. So we need to find actually T1 and T2 the value, and definitely yes, AC is in tension and BC is in compression. So let's see how much tension and compression force is there in both these strings. So for that we can like go with the conservation like net tau, because system is in equilibrium. So I can write tau about A must be 0, and this implies mg into this distance. This distance is equal to what? It's 1.6 into sine of this, that is B, minus, because I am talking about tau about A, so due to this there is no torque due to T1, and due to this it will be having some torque. So like I am extending it parallel to this, then this is the perpendicular distance, this is beta, this will be also beta, then I can write 0.6, so this distance will be like 0.6 into sine beta, correct? So this is equal to T2 multiplied by perpendicular distance 0.6 multiplied by sine of B equal to 0. Sine B getting cancelled, and this implies T2 is equal to M 5 into 10 into 1.6 divided by 0.6, and that comes out to be T2 is equal to how much? This is 8 and 4000 divided by 3 Newton, and that's in compression. So here option BC is in compression with force 400. No, BC is in compression with force of 4000 divided by 3. So C is correct option. And similarly I can write next equation where tau B is equal to 0. In that situation, torque due to this can be written as exactly same mg into 1.6 into sine of B minus next due to this. So for that I will be right this parallel, and here also this parallel. So in this situation this is A, and this angle will be becoming like pi minus A. Now this will be like what? 0.6 into sine pi minus A. So this comes out to be T1 into 0.6 into sine of A equal to 0. Similarly, solving here, we get T1 is coming out to be 1000 Newton. Simplifying, so question number 6, we are getting actually T1 means AC is in tension with the force of 1000 Newton, and BC is in compression with a force of 4000 divided by 3. So here option A and C are correct. A and C are correct options. Next question number 7 and 8. Okay, next question number 7 and 8, that is based on one paragraph. Let me read it first. Cylindrical block of density 2 gram per cc suspended by thin wire of length. So its length is 3 meter and this density of this is 2 gram per cc. This block means rho is 2 gram per cc. When the wire is vibrated, it produces fundamental frequency. So the fundamental frequency of this wire f0 is 280 hertz. And the mass of the wire is so small that tension in the wire can be assumed to be constant. Now the block is dipped in a liquid. It is found that the first overtone now is, so means it is fundamental, then its first overtone, that's coming out to be also 2 hertz, same frequency, but it's not fundamental, it's this time it's first overtone. So tension in the wire T can be written as T is equal to what? Because of its weight, that it can be written V rho into G. And now in this situation, T prime will be equal to V rho G minus V into sigma into G, that is equal to V G into rho minus sigma. So let me say the tension in this is T, and that is equal to this, and linear mass density of this wire is mu. So then I can write F0 is equal to 280 is equal to 1 by 2 into L. L is 3 meter under root T. T is V rho G divided by mu. This is from condition 1. In this situation, the frequency become first overtone, that is equal to 280, that will be equal to 2 divided by 2 into L, 3 under root, this is V G rho minus sigma divided by mu. So we got these two relations. Simply like comparing these two, so these two things are equal, and just this implies 1 by 6 under root V rho G divided by mu should be equal to 2 by 6 under root Vg rho minus sigma divided by mu. So 6 gets cancelled, mu gets cancelled, Vg gets cancelled, and we are left squaring it. So this is rho is equal to 4 times rho minus sigma, and this is 4 sigma is equal to 3 rho, and sigma is equal to 3 by 4 into rho is 2, that is equal to 1.5 gram per cc. So this is the answer for question number 7. 7 we are getting it's 1.5, that is means it is matching with option B. Question number 8. Now it's saying if the block is dipped to 1/3 of its height in the liquid, what is the new fundamental frequency? So now remember, it's asking in this situation new fundamental frequency, and the block is submerged only 1/3. So now it's not completely submerged, it's dipped only 1/3. So it's this volume is only V by 3. So in this situation, the tension will change. Tension will be V by 3 into this, or you can write divided by 3. This is, so now I can write new fundamental frequency F0 prime will be equal to 1 by 2 into L, 3 under root V G rho minus sigma by 3 divided by mu, and we can simplify it from here, because in that case 1 by 6 under root Vg, this is rho minus sigma, simply rho divided by 3, like mu. If I just simply dividing it, then I will not require to calculate the value of mu, otherwise we need to substitute the value of mu. So simply dividing it, this is 280, this is getting cancelled, everything mu gets cancelled, V and V and G getting cancelled. So this is F0 prime divided by 280 is equal to this is under root V gets getting cancelled, so it's 2 minus 1.5 divided by this row will be still there 2, and this implies F0 prime is equal to 280 multiplied by its root 3 by 4, and F0 prime is coming out to be 140 root 3 hertz. So this is the fundamental frequency in second case when the block is submerged to 1/3 of its height. So that is about question number 8. Okay, next question number 9 and 10, that is also based on one paragraph. Let me read it first. So de Broglie's hypothesis thesis state that every material particle is associated with a wave number, wave known as matter wave. The wavelength of matter wave is given by lambda is equal to h by mv h by p, where h is Planck constant. When we use this in Bohr's theory, it shows that angular momentum of electron in a hydrogen atom is quantized, that we know already. The same principle can be applied to a particle of mass m moving in a circular path. So now it's saying the principle of quantum, like angular momentum to be quantized, that principle is supposed to be used here also in that situation. So if the particle is moving in a circle of radius r with the velocity v, where v is the velocity or speed of the particle, in that situation its angular momentum mvr I can write by using the same quantization principle for angular momentum. I can write this is also equal to nh by 2 pi. So we got one relation. This another, let's say, normal direction, this mg weight will be acting in this manner. So I can write n cos theta will be providing required centripetal force mv square by r, and n sin theta is balancing the mg. So this is all happening. Now it's asking the minimum height h of the particle, where it can stay by following in applying these restrictions, these conditions. What can be the minimum value of h? Let's calculate that. So by just simply dividing this by this, I'm getting here tan theta is coming out to be g divided by gr divided by v square, and this implies v is equal to under root gr divided by tan theta. Now you can substitute it here. So this is m into under root g by tan theta into r power 1 by 2 and r power 1, so it's r power 3 by 2 is equal to nh divided by 2 pi, and this implies the value of r 3 by 2 is equal to nh divided by 2 pi m into tan theta divided by g. So this is power half, and power 3 by 2, just making it here 2 by 3, and here it will be 1 by 3. So we got the value of r. Now I can write here tan theta is equal to what? R by h. So h is equal to r by tan theta, and then I'm getting h is coming out to be the same thing, nh divided by 2 pi m into power 3 by 2 into this is tan theta divided by g power 1 by 3, and this tan theta 1 by tan theta. Simplifying, I'm getting this is nh divided by 2 pi m power 3 by 2 into this is 1 by g power 1 by 3, and that will be tan theta will be added here. So into tan theta with the power 3 by 2, it was 3 by 2, it will be 2 by 3 actually. 2 by 3, this will be also 2 by 3 because tan power 1 by 3, and here it will be tan power 1. So 1 minus 1 by 3, it will be 2 by 3 in the denominator, and then here it's left 1 by g power 1 by 3, or this way also. Now this is the value of h, and now as n increases h will be higher, so the minimum value of h will be h minimum for n is equal to 1. This comes out to be h minimum is equal to h divided by 2 pi m tan theta power 2 by 3 into 1 by g power 1 by 3. So this is the answer which matches with option g power 1 by 3 and cos theta sin theta. It's A is correct option for question number 9. Next, total energy of the particle is, n is an integer. So total energy of the particle, that is question number 10. Total energy of the particle, so E will be equal to kinetic energy, that is half m v square plus potential energy mgh. V square, if I substitute it from here, then it comes out to be mgr divided by 2 tan theta plus mg into h is also equal to what? H is equal to r by tan theta. So this is also r by tan theta. So then I am getting basically 3 by 2 mg by tan theta multiplied by r. Substituting these values, because r we already got it. So this total energy is coming out to be, this is 3 by 2 mg into like by tan theta into this is nh divided by 2 pi m power 3 2 by 3 into tan theta divided by g power 1 by 3 uh, h tan theta divided by g into power 1 by 3. That's okay. So this value is substituted, simplifying it, e here 3 by 2 m power 1 m power minus, so it will be m power 1 by 3 g power 1 and g power minus, so g power 2 by 3 into tan theta power 1 and tan theta power 2 by 3 like 1 by 3, so it will be 2 by 3, and this is nh divided by 2 pi and tan theta and whole power 2 by 3. So that should be the value of energy, which is 2 by 3 and m power 1 by 3 g power 1 by 3. All right, g power 2 by 3 3 by 2. Yes, so it matches with option B. So here B is correct option. So this is about question number 10. I hope you understood up to here. Okay, next section 2, question number 1. The question is, in figure a rod of mass 1 kg is held. So this is a rod of mass small m is given as 1 kg, is held vertically by an unknown mass capital M hanging over a pulley as shown in this. So this is the mass capital M, which is still unknown. Assuming small h is given as 50 centimeter and capital H is given as 100 centimeter. Find the minimum value of capital M in kg that make the equilibrium system stable for small displacement. So what it means? So means initially this is the position of the system. Now if we are displacing it a little bit, so now what will happen? Actually this weight small mg will try to bring it like displace it more or disturb it more, and this tension in this string T will try to bring it back to the same position. And we must understand the meaning of simply stable equilibrium means this should be like this effect, this tension effect must be dominating so that it can restore back to its original equilibrium position. If this is dominating, then it will be in unstable equilibrium. So now we can just balance the torque, or we will write this should be greater than 0, or like net torque, or I will say the torque due to this should be just greater than or equal to this, then it will be in stable equilibrium. So that we can write, so this is alpha, this is beta, then tau about this point O, so tau about O, so this is 1 is mg into this distance is how much? Perpendicular distance h by 2 into sine of alpha minus tension, it's T, and T will be equal to what? T will be equal to capital M into Z. So T into this distance perpendicular, so that can be written as basically this total capital H into sine of beta, and sine, if I take this distance as x, then I can write sine alpha is equal to x by h, and sine beta is equal to x by capital H minus small h. Substituting these values there, mg h by 2 into x by h minus t into capital H into x by capital H minus small h, or this should be dominating means I can write this should be less than 0 or equal to, so let's just simplify it for t equal to like this complete equal to 0, and that implies x gets cancelled, small h gone, and t can be written as capital M into G, and just let me simplify it, so we are getting this GG also gone, so this capital M is coming out to be small m into capital H minus small h divided by 2 times of capital H. Substituting these values, m is equal to 1 kg, this is h 1 meter minus 0.5, so it's 0.5 meter divided by 2 into h is 1, so then it's coming at 0.25 kg. That is the answer to question number 1. Next question number 2. So an inductor, resistor are connected in single loop. Single loop means in series. The current reduces to 0 from its maximum value at t is equal to some t naught. The energy converted to heat equal to the energy stored in the inductor at that time. Find the value of t naught. If t naught is equal to some x by L, then find x. Okay, so that is the question. So here one inductor and resistor, they are connected, and initially I can write t equal to 0. I is some maximum current I naught. So energy stored initially, I can write total energy will be in inductor, that is a half L I naught square. Let's say let at time t naught, the current in the inductor, current is I. Then what is the energy still left in the inductor? So energy in L at this time can be written as half L I square. How much is the energy getting lost in the heat, in the form of heat in the resistor? So E heat, that can be written as half L I naught square minus half L I square, and it's given this energy stored and this energy lost are equal, and this implies half L I square is equal to half L I naught square minus half L I square. This implies half gone, L gone, and I, so 2I and I naught, this implies I is equal to I naught by root 2. And we know for this system I is equal to what? I naught e raised to power minus t L RT divided by L. So this is I naught by root 2 I naught e power RT by L. Simplifying it, this comes out to be this is at T naught, so RT naught by L, this is ln 2, and ln 2 divided by 2, and this implies T naught is equal to L ln 2 divided by 2 into R, and that's what. So this implies T naught is equal to 0.69 into L divided by 2R, and that comes out to be 0.345 L by R. So here the value of X is 0.345 something. That's the answer to question number 2. Okay, next question number 3. Capillary tube with very thin wall is suspended vertically in a cup containing water. Before the capillary is suspended, the cup was balanced against weight on some beam. So let's say it was balanced against some W0 weight. Now when the capillary is dipped to a small distance in the water, water rises in the capillary, water completely wets the capillary walls. To restore the balance, we have to decrease the load. So let's say finally load is W prime, then it's W0 minus W prime is given as 0.14 gram weight. Is it? If the surface tension of the body is 0.07 Newton per meter, this is surface tension. Determine the radius r in mm of the capillary. Question is simple, straightforward if you are understanding it. So here, whatever the weight is decreasing, that is because of the upward force applied by this capillary on the liquid. So we need to calculate that F upward force, that is equal to on this and due to this surface. So it's like 2 pi r, if r is the radius of the capillary multiplied by t, and similarly here also it will be plus 2 pi r into t, so it's coming out to be 4 pi r into t, and that's equal to 0.14 into 10 to the power minus 3 into g, that is 10. So now we need r is equal to 0.14 into 10 to the power minus 3 into 10 divided by 4 into pi into t is 0.07. Simplifying it, this is 2, this is all, and here this is coming out to be 2, this is 2, so 1 upon 2 pi, this is and r is equal to, if I'm it will be in meter, mm, then it's gone, and this is 10 divided by 2 pi, so I can write 5 over pi, and 5 into 7 divided by 22 into 10, that's in mm, and simplifying it, it comes like 35 divided by 22, that will be like some 1.59 mm. That is the radius of capillary for question number 3. Okay, next question number 4. The working substance of heat engine is monoatomic ideal gas. So it's monoatomic ideal gas. Ideal gas. Determine the efficiency in percentage of heat engine if the cycle is shown in the figure. So it's running from 1 to 3 across this V0, 4 V0, and this is P0, 4 P0. So if I'm taking temperature here, it's T0, then here temperature will be like 4 T0, and here temperature will be 16 T0. So you can see it's from 1 to 2, its temperature is rising, so means it's absorbing heat. From 2 to 3, temperature is falling, so means it's rejecting some heat. Let's say some it's getting absorbed Q1, this is Q2 and Q3. So this is the heat rejected. Then efficiency eta is equal to W divided by, I can write it's Q1. And for complete cyclic process, I can write Q1 plus Q2 plus Q3 will be equal to W. Q2 and Q3 will be actually negative. So Q1, then I can, W is equal to simply area under this triangle, that is coming out to 1 by 2 into, this is how much, 3 V0, and that is 3 P0, that's 9 P0 V0 divided by 2 is the W, work done. And it's easy to calculate Q2 and Q3. So Q2 will be equal to N CV delta T. Delta T is equal to what? 12 T0, and this is like N into CV, it's 3R into 12 T0 divided by 2, and this is coming out to be 36 NR T0 divided by 2, and this NR T0 can be 36 P0 V0 divided by 2. Similarly, and it will be basically negative, negative, all negative. Q3 will be minus of N CP delta T, that is N into CP is 5 by 2 into R into delta T is what? 3 T0. 3 T0. So this comes out to be 51. So this is a 5 in 15. This is minus 15. Again, exactly NR T0. Then I can write P0 V0 divided by 2. So this is Q2. Then Q2 plus Q3 is coming out to be minus 51 P0 V0 divided by 2. Then by using this relation, I can write Q energy supplied. Q1 is equal to 9 P0 V0 by 2. W plus 51 P0 V0 divided by 2. So Q1 is equal to 30 P0 V0 divided 30 P0 V0. Then eta efficiency is equal to W divided by Q1 multiplied by 100. That's 9 P0 V0 divided by 2 into 30 P0 V0 multiplied by 100. This is gone. 300 divided by, it's like 2 multiplied by 10, it's 1510, so it's 15%. This is the efficiency of heat engine. Simple thing, W work done is area under this graph, that's what we are getting here. It's easy because we don't know this process 1 to 2, so it's easy to calculate for this and this. Q2 Q3 we have calculated easily, and we got this, and Q1 plus Q2 for cyclic process equal to W. From there we got the heat supplied, and eta divided by, like eta is equal to W divided by Q1 and multiplied by 100. Simplifying it, we are getting it's 15%. That's the answer for question number 4. Okay, question number 5. So find the equivalent resistance in ohm across source if E is given as 10 volts. So across source means across these two ends. Resistance of all resistor is same in R, and that is equal to 68 ohm. So it's simple series parallel combination here. These two are in series, like in parallel, then it will be like equal to R by 2 plus in series. So it's basically 3R by 2, 3R by 2 in parallel with this. So 1 by 3R by 2 plus 1 by 2R, then it will be like 6R by 7, and plus this in parallel, series, then it will be like 13R by 7. So this complete up to here, it's 13R by 7. Now plus 3R in parallel basically. So 1 by 7 by 13R plus 1 by 3R, that comes out to be 39R by 34. And plus this R, so this R, that is equal to R equivalent. So R equivalent, we are finally getting 39 into 68 divided by 34 plus R, that is 68. So this is 2 and this is 78 plus 68, that comes out to be 146 ohm. So R equivalent across the source is coming out to be 146 ohm. That is question number 5. Next, question number 6. a boat runs between points A and B. So this is a river. So given boat runs between A and B points. Let me draw the diagram. So this is a river, and here is the A point, this is point B, and this is angle alpha, this is point C, and the boat is constantly on the line AB. Point A and B are at a distance. So AB distance is mentioned as 1200 meter from each other. The rate of flow of the river, so UR is 2 meter per second. Line AB make an angle alpha is equal to 30 degree with the river flow, with the direction of the river flow. What is the speed V in of the boat with respect to water if boat has to go from A to B and get back in 20 seconds? So first thing is like boat definitely has to drive at some angle beta. Let's say V is the speed of boat with respect to water or river flow. In that situation, because it's mentioned boat has to move across AB, so that means the component along this, that is V sine beta, and this is VR, that is actually UR. So UR into sine alpha must be equal V sine beta must be equal to UR sine of alpha. One relation we got this. Net velocity along this is how much? V cos beta plus UR cos alpha, and when it is coming back, this will be your still UR, and then again VR will be at some angle beta. So here this is again we can take some angle. Then in this situation, when it is coming back, so here UR will be along this, and with this angle is still given as alpha, so its component along this will be still U sine alpha. So that means it is also exactly same, so that this component must cancel, and when boat is coming back from B to A, then again net velocity must be along BA. Now net velocity must be along AB. So in that situation, if this is alpha, then component along this will be UR sine alpha. So then we can say VR is remaining, V is remaining constant, so means beta will be also exactly same as, so that these two components are cancelling out. Then initial velocity from A to B is this, and velocity from B to A will be, this is V cos beta minus UR cos alpha, and then total time is equal to 1200 distance divided by, this is V cos beta plus UR cos alpha, plus this is also 1200 divided by V cos beta minus UR cos alpha. So this is the given, and it's mentioned the time must be 20 minutes, means 20 into 60 seconds. So this much second. Now this 1200 gone, so we are left with this, and here it comes out to be, this is, if I'm taking LCM UR cos, so this is 2V cos of beta divided by, it will be V square cos square beta minus UR square cos square alpha, and that should be equal to 1. So let me erase and simplify it further. Next, simplifying it further, so we are getting it's 2V cos beta, this is V square cos square beta minus U square. U is given as actually 2 meter per second U, yes, and alpha is given as 30 degrees. So let me substitute. U square means 4 into cos square alpha. 4 cos square alpha is 3 by 4, gets cancelled, and this is equal to what, like that's all. So this quantity equal to this is V square cos square beta minus 2V cos beta minus 3 equal to 0. Then V cos beta is equal to 2 plus minus under root 4 plus 4, it's 12 divided by 2, that is 2 plus minus under root 16 divided by 2, so 2 plus minus 4 divided by 2. So here v cos beta cannot be negative, so it's v cos beta is coming out with 3, and from here this condition I can write v sin beta is equal to what? U 2 into sin alpha 1 means 30 degree, that is equal to 1 meter per second. Then squaring and adding these two, so v is coming out to be under root 3 square plus 1 square, v is equal to under root 10, that is 3.16 meter per second. So this must be the speed of boat with respect to water or river flow for the boat to cross along AB in the given condition, given time interval. Next question number 7. Okay, next question number 7. So a homemade illuminator is a cylindrical tube of radius 10 mm with a black inner surface. A point source of light is located on the tube axis at a distance of 20 centimeters. So this is the lens. This is a tube whose inner surface is black, so means light is not coming out of this tube, it's coming out from this lens only. And then this D is mentioned as it's 20 centimeter. The screen is placed in front of the illuminator at a distance such that sharp image of the point source of light is produced on a focal length of the lens. So focal length of this lens is also given as 15 centimeter. So let me first get the distance where screen must be placed so that we are getting sharp image of this point source, so that we can be written as it's UF divided by U plus F. Substituting the values, U is minus 20 into F is 15 divided by minus 20 plus 15, and this implies V is coming out to be minus 20 multiplied by 15 divided by minus 5, this all 4, that is equal to 60 centimeter. So means from this lens the screen must be at a distance of 60 centimeter. Now what it's saying, what will be the inner radius of circle of light in centimeter directly from source on the screen if you remove the tube and just keep the remaining arrangement as it is. So you need to understand this language. What it's saying is that initially what is that happening, like this light, this source, whatever the light is coming only passing through this lens, so no light is coming here. Now it's saying if this tube is removed, remaining things are kept constant, then what will happen, actually light will be coming from, because whatever the light passing through the lens, that all will be converged at this point source or image. So remaining like there, here what will happen, actually from this region no light will be reaching here, so there will be dark. Now whatever the light is like going beyond this radius of this lens, so this light will be falling here, so this is the image, and up to here there will be a circle on this screen. You can imagine this will be a circle, so this radius is asked, actually let's say R prime, and that we can calculate very easily. So this distance we know it's 20 centimeter, this is 60 centimeter, and this R is given as 10 mm, so that will be equal to 1 centimeter. Then it's like simple triangle, I can write this is let's say R, and this is R prime, and this is distance, so I can write R by D will be equal to R prime by this total distance, that is D plus 60, and this implies R prime is equal to, it's 80 divided by 20 multiplied by 1, that is 4 centimeter. This is the answer, actually it's asking for question number 7. So what is the inner in centimeter? That's 4 centimeter answer. Next question number 8. A bimetallic strip is made of two carefully polished flat plates. So here we have bimetallic strip, and what it's saying is that a silver one surface of the metallic strip, one is silver, another is lithium. So this is bimetallic strip. The plate is placed in vacuum and the surface of the silver is illuminated. So silver surface is illuminated with light, illuminated normally by monochromatic light beam of violet light with the wavelength of violet 0.4 micrometer basically. Plate is now turned by 180 degrees, so now what happened, actually now plate is turned by 180 degree means lithium is exposed, silver is now facing down. Plate is now 180 degrees, so that So lithium surface faces the light. What is the ratio of saturation current from silver to saturation current from lithium? Assume that photoelectric efficiency in both the cases. So efficiency of photoelectron is 0.01, and that all photoelectrons are emitted normal to the surface is as fast as possible. Work function of the lithium. So phi for lithium is mentioned as 2.5 electron volt, and phi for silver is mentioned as 4.5 electron volt, and mass of the electron is also given 9 into 10 to the power minus 31 kg. So wavelength of the light incident, that's given by 0.4 micron, that can be written as 0.4 into 10 to the power minus 6, so that is equal to 4000 multiplied by 10 to the power minus 10 meter. This is the wavelength. Let me first calculate the energy of incident photon. So energy of photon, E photon, that is equal to what? 12,400 divided by lambda in angstrom, and this comes out to be 12,400 divided by 4,000, and this is double zero gone, it's like 31 divided, so it's 3.1 electron volts. So we have something interesting here, is that the energy of photon incident is only 3.1 electron volt, and the work function for lithium is 2.15 electron volt, for silicon 4.5. So do you think like this photon will be able to eject electron from the silver? It's definitely not. Now what it's asking is that assume that okay, what is the ratio of the saturation current from silver? So I silver to I lithium, saturation current lithium. So definitely in this case no electrons are ejected. So what is the ratio? Current 0, and here whatever the electron is ejected, whatever the current is there, we don't need even have to calculate in this situation, because simply 0 divided by anything not equal to 0, because definitely in this case lithium is having work function less than this energy, so definitely some current will be there, that will be non-zero. So 0 divided by something, so we will be getting answer simply 0 straightforward. So this is all about your paper 1 for FST 23. I hope you are clear with all your doubts and whatever you were facing in this paper. So thank you, that's all, see you next day.